Alright, welcome to the Explainer. Today we are opening up the case file on one of the biggest, most tantalizing mysteries in all of science, the search for life on Mars. So what if we've already found life on Mars and just didn't realize it? It's a pretty wild thought, right? To even begin to unpack that, our investigation has to start way back, not with a high-tech rover, but with a simple telescope and an idea so powerful it grabbed the whole world's attention. Okay, so let's set the scene. We're going back more than 100 years. Astronomers are pointing their telescopes at the night sky, looking at Mars, and they start seeing something strange, something that didn't look natural at all. In fact, it looked, well, artificial. And this discovery, or what they thought was a discovery, kicked off a total global sensation. So you had these astronomers, guys like Giovanni Schiaparelli and especially Percival Lowell, and they weren't just seeing smudges. They were mapping out this incredible network of long, straight lines they called canali. Lowell was absolutely convinced. He put forward this whole theory that Mars was a dying planet and an advanced civilization built these massive canals to bring water from the polar ice caps down to their cities. It was this epic story of survival. But as we now know, high-resolution pictures from space showed us the truth. They were just optical illusions. Our brains were basically playing connect the dots with craters and canyons. And Lowell, he went all in on this. He wrote books about it, gave lectures. He was basically the biggest cheerleader for Martian life. For him, the straightness of these lines, their sheer scale, it was an unmistakable sign of intelligent design. There was no other explanation in his mind. It had to be the work of Martian engineers. But, well, science marches on. Our telescopes got better, and then we started sending probes, and the pictures that came back were crystal clear. No canals. Not a single one. It was a tough pill to swallow for a lot of people. So chapter 1 of our detective story slammed shut. The case of the canals was officially closed. But you know what? It just made us want to find the real evidence even more. We knew we had to go there ourselves. So, fast forward to the space race. This is where things get really exciting. The Soviet Union decided they were going to be the first to actually land one of our robotic investigators on the scene. And let me tell you, this was an unbelievably difficult challenge. They were pushing the absolute limits of what was technologically possible at the time. And boy, was it tough. The first few tries were just heartbreaking. Mars 1 just went silent on the way there. Then the Mars 2 lander came in too fast and just crashed. But then, 1971, Mars 3. Against all odds, it actually made it. It achieved the first ever soft landing on Mars. Think about that. For the very first time, something we built was sitting on the surface of another planet. And you can just feel the emotion in this quote from one of the scientists. I couldn't hold back my tears. I mean, can you imagine? After all those years of work, all the failures, to finally get that signal confirming you've landed, it must have been an absolutely incredible moment. A huge, monumental achievement for all of humanity. But that incredible high, it didn't last. The triumph was so brief. After just 14 seconds, the transmission just stopped. The line went dead, and the only image they got back was this. Gray, fuzzy, nothing. The planet's secrets were safe. Our first investigator had made it to the crime scene, only to be silenced before it could report back. Okay, so now we get to what might be the single most mysterious, most debated piece of evidence in this whole cosmic detective story. We're talking about NASA's Viking landers in 1976. This is where things get really weird. And the argument that started back then, it's still going on today. So, the Viking landers weren't just cameras. They were carrying these amazing little automated biology labs. And one experiment in particular, the labeled release experiment, or LR, was just genius. The idea was simple. You scoop up some Martian soil, you add a little broth of nutrients, kind of like chicken soup from microbes. But this soup is tagged with radioactive carbon-14. Then you just wait. If there are microbes in the soil, they should eat the soup and then, breathe out radioactive gas. It's a fantastic direct way to look for metabolism. And then, it happened. When they ran the experiment, the results that came back were just shocking. The radiation counter started ticking up, and the graph it produced looked exactly like what you'd see from a thriving colony of bacteria here on Earth. It was a perfect, textbook positive result. For a moment there, it looked like they had done it. They had found life on Mars. But then came the twist. The team was so excited, they decided to add a second dose of nutrients, expecting, an even bigger reaction. But instead, the signal flatlined. It just died. That made absolutely no sense from a biological perspective. If you give hungry microbes more food, they get more active. They don't just keel over. It was bizarre. It was almost like the second dose of food had somehow poisoned whatever was in there. And this contradiction created a firestorm of debate that has lasted for decades. I mean, look at the evidence. You have a positive result that looks biological. The sterilized control sample did nothing, just as you'd expect. And you got the same results from two different landers thousands of kilometers apart. But on the other hand, the reaction stopped when you added more food. And this is a big one. Another instrument on Viking found no organic molecules in the soil. So the scientific community kind of settled on an explanation. It must be some weird exotic Martian chemistry, not life. And that moment totally changed the game. The focus shifted from finding living things to looking for the chemical clues that life might have left behind a long, long time ago. Which brings us to today. Let's jump forward and see how our modern rovers are tackling this cold case. Because now they are basically rolling, sophisticated forensic labs designed to find the very clues that Viking just couldn't see. So yeah, the whole strategy has changed. We're not so much trying to feed potential microbes anymore. Instead, the hunt is on for what we call biosignatures. These are the chemical fingerprints that life leaves behind, the building blocks themselves. We're talking about specific, complex molecules that are really hard to make without biology. And this is a great way to visualize that new approach. A rover grabs one sample of soil or rock, and then it can run a whole bunch of different tests on it at the same time. You might have one test that uses a chemical that changes color if carbohydrates are present, and another one specifically looking for proteins or ammonia. It's exactly like a forensics team back at the lab, building a complete profile of the evidence. Yeah, our robotic detectives today are just kitted out with an incredible suite of tools. They've got sensors that can literally sniff the air for trace gases. They can check the pH of the soil to see if it could have supported life. They have super-powered microscopes to look at rock textures up close, searching for those tiny telltale signs of ancient microbes. And very recently, these new advanced tools have picked up on a brand new lead, one that has basically reopened the whole case with a jolt. And that is the mystery of methane on Mars. This, right now, is one of the hottest clues in the entire investigation. See, here's the thing about methane. It's fragile. In the harsh Martian atmosphere, with all that sunlight and radiation, it should get destroyed in just a few hundred years. So the fact that we're seeing it at all means something has to be actively making it right now. It has to be coming from somewhere, either from some kind of geological process deep underground or from biology. But just like with the Viking results, the evidence here is confusing. It's a real puzzle. We have the Curiosity rover down on the surface, and when it takes measurements at night, it consistently picks up these little puffs of methane. But then we have the Trace Gas Orbiter flying high above, looking down during the day, and it sees nothing. Absolutely zero. So what is going on? Well, the leading hypothesis is pretty cool. It suggests that methane is playing a cosmic game of hide and seek. The idea is that at night, when the air is still and cold, tiny amounts of methane seep up from the ground. But then, during the day, the sun comes up, the atmosphere starts churning, and that little bit of methane gets mixed up and diluted so much that from orbit, you just can't see it anymore. And that brings us right back to the million-dollar question, doesn't it? What is making this stuff? Is it just rocks and water reacting deep underground? Or could it be the signature of life, the modern-day breath of Martian microbes hiding beneath the surface? Right now, nobody knows. The case is still very much wide open. So, is Mars just really good at hiding its secrets, or are we, after all this time, finally learning how to ask the right questions? From canals that weren't there, to experiments that gave us both a yes and a no, to mysterious gases that play hide and seek, this entire search for life on Mars is really a search for our own place in the cosmos. It's the ultimate detective story, and you just know the next big clue is waiting for us right over that next red horizon.